make sure phones are switched off. If any of you are wondering, did I switch my phone off? Better to go and check it in your bag now than for us to hear it and be interrupted. I'll be less than impressed if that occurs. Go and check if you're not sure. Nearly there. Ladies and gents, whilst we're just waiting for one or a few people to be seated, this time last week we did the first ever walking talking mock, and by the end of it I was kicking myself. You may have noticed that I filmed a small extract of it. I was kicking myself because I realised there was an opportunity that we missed. The opportunity that we missed last week was to video the whole thing. Because what we intend to do, and it was an idea that came from last week, was we intend in January to set up a Shoreham Academy YouTube revision channel, basically. So just have a YouTube account which has got a series of revision videos. Because I've recognised, speaking to several students, for a start, the feedback from you guys was very, very positive about what this was like last week. The feedback from teachers who got to see this. We will be looking to do this in other subjects. And what one or two people said was, it was really great to see that method explained so clearly. Okay. So what we're going to do is we're going to chunk it up into 4 or 5 different chunks. It's going to be there is the walking talking mock paper for a calculator. We'll do it again next year in the spring so that we've got a non-calculator paper. So then when you want to remind yourself of the methodology, how you actually go about that process of solving a particular question, you're going to be able to go to that particular clip. And we'll have the same thing for other subjects as well. So science, English, PE, all of the different option subjects. If it's appropriate for those subject teachers, they're going to look to do similar things. So you've got those clips to be able to revise from, to have method explained to you about how you get the best grades. So that's why there's another camera in addition to the visualizer down here. The camera's not fixed on you. All it will do is record what's being seen by you up on the screen. Now last week it was outstanding. Okay, absolutely fantastic. My expectation, I'm going to mention it now, but I only need to just touch upon it. My expectation is that you keep your focus and your attention for the duration of this exam. Okay? It sets you up for the paper that you then go on to sit tomorrow. So our expectation is that everything that the teacher is writing on the paper, up on the screen, is something that you will also write on your paper as well. So that you get used to the idea of showing the right level of writing your work. Okay? So, you know what I expect of you. You managed to maintain that last week. I was really, really impressed, as I said in the exam on Friday, really, really impressed with the way in which you've approached the mocks, and I see no reason for that not to continue with this particular paper today. Okay, so over to you, sir.
Okay. All right, good morning, Year 11 then. We will go through just the same as we did last week, myself going through a few questions, then Miss Burgess doing a few and just alternating. Those that haven't quite got a calculator yet, we're just coming around hopefully with a spare. So please make sure you've got your calculator. Can you just turn them on? Make sure that it works. Make sure that 2 add 2 does give you the answer you want it to. Okay. Make sure you understand what calculator you've got. And hopefully, as we're going through it, okay, because we didn't have this last week, obviously, but we will be trying to show you the calculator bits that we're doing as well. So hopefully you can see that. Won't be quite as clear as the pen, but you should be able to kind of see and focus on what we're typing in the calculator. When we hit equals, when we use brackets, all of those little things that sometimes the little errors that we get wrong. Okay, so just what we type on there is just as important as what we write down on the paper. So if you'd like to start, just turn over to question 1. And straight away, as kind of per usual for a calculator paper, you've got your calculator question. There is no math skill really involved in this other than can you type these numbers in the right order and get the right answer. Okay, so the first thing to kind of have a look at, you've got a big square root and then 2.56 plus 3.50 on top. Then you've got your division and you've got the 8.765 take away the 6.78. Okay, it is worth doing all of this separately. If you try and put this into the calculator in one go, chances are it will go wrong. Calculators don't automatically know what you want them to do. Okay, you do have to force the issue slightly. So my first step would be to actually look at the inside of the square root bit and physically work out 2.56 add 3.5. Okay, it's a calculator paper. No matter how simple the calculation, you might as well use the calculator. Don't even potentially make any little mistakes. So 2.56 add 3.50. Those that have got this Casio, okay, I'm quite glad mine did this now. If you've got the Casio calculator, that happens quite a bit. When you do a question, an add or divide, it comes up with a fraction. Don't forget, it's this button here, okay, the one with the S and D on. That's the one that converts it from the fraction to the decimal, okay? So you want to be working with decimals. So our answer to that simply was 6.06, okay? What the question is then, is on top, it's the square root of the 2.56 plus 3.50. So we want to square root 6.06, okay? Again, do it as a separate calculation. Do it bit by bit. So I'm going to clear it. There's my square root button, okay? It gives me a little box to fill in. I put my 6.06. Get my equals, again it does the fraction, so I just turn it into the decimal, okay? And at this point I want everything. I don't want to cut any of that. I do want all of these digits. So 2.46, I'm just going to literally copy them all down. Okay, don't miss any out, make sure you've got everything. That's the top of that question. We've still then got the bottom. Okay, the bottom then, 8.765, take away 6.78. Okay, again, totally separate calculation. Plug those in, hit your equals, again I've got to do that, and 1.985. Okay, this is just then the bottom of that question. You've done everything we need to do now, it's just about finishing it off. In which case it's the 2.46, that big decimal on top, divided by the 1.985. Okay, so carefully type it all back in. Divided by 1.985. Okay, and the question does say write down all the figures, so nothing goes missing. 1.2401545, okay, 21. And they are expecting all of that. Unfortunately, if you do miss one or two of those numbers, you will lose one of those 2 marks for it. Okay, so make sure you got everything. Part B then, give your answer to an appropriate degree of accuracy. Now we tend to give things in maths to 3 significant figures. That is our appropriate degree of accuracy. So when we say that, we're looking, 1 is our first significant figure, 2 is our second significant figure, and the 4 is our third significant figure. So we want to make sure we include those 3 digits in our answer. You just have to look at the next one as well, because that 0, that's the number that tells you, do you round up or do you keep it the same? Okay, now a 0 means we don't have to round, so our answer is just 1.24. Okay, remember if that 0 was, say, a 5, 6, 7, 8 or 9, that's when you'd have to round that 4 up slightly. Okay, question 2. A man left home at 12 noon to go for a cycle ride, okay? You can see the travel graph there represents part of the man's journey. So you've got distance from home on the left in kilometres, and you've got the time of the day along the bottom. Part A. Just try and get the graph on as well. At 12:45, the man stopped for a rest. How many minutes did he rest for? So the resting point will be that part of the graph that hasn't moved. It's a horizontal line, okay? How many minutes did he rest for? We've got to basically work out what one of these little boxes is worth, okay? Don't just presume it's 10 minutes. Don't presume it's 5 minutes. You do have to look at the scale. In between 12 and 1 o'clock, there are 1, 2, 3, 4 boxes. Okay, so you need to split 1 hour into 4 even amounts, which would give you 15 minutes then, okay, for each of those 1 squares. So he rests for 1 square, which is 15 minutes. Find his distance from home at 1:30. So essentially, where's 1:30, and find out how far he is away from home at that point. So look to your graph, figure out where 1:30 is, right in the middle of 1 and 2 o'clock. Okay, use a ruler, do a neat line upwards, just so you get a nice focus on where the line is. And then when you draw the one across, okay, we should find that it's right in the middle of 14 and 16. So again, that is 15 kilometres. And they've probably given those 2 numbers as 15 deliberately. Okay, so just be careful. Don't think because it's one, it's got to be the other. They probably have thought about that beforehand. Last part then, the man stopped for another rest at 2 p.m. He rested for 1 hour. So our line finishes at 2 p.m. He's going to rest for an hour, so we need a horizontal line that just covers 1 hour. So be careful, look where your 2 o'clock is, look where your 3 o'clock is, and make sure you only have your horizontal line for those 4 squares. Okay, 4 squares would be 15 minutes each. He then cycled home at a steady speed. It took him 2 hours. So from where he is now, he's got to get all the way back home in 2 hours. So 3 o'clock, 2 hours later would be 5 o'clock, and then it's one straight diagonal line all the way from the edge of his rest point down to the 5 o'clock. Okay, nice straight line. They would expect rulers, any freehand, and you will lose the mark. So please use a ruler. Okay, question 3. again, an angle question. They've put their diagram not accurately drawn. That's your little cue to say to yourself, there's no good me measuring this. It's not going to help. It's just about looking at the parallel lines and the angles that they give you. The line BA is parallel to EGD. Okay, so basically that line BA is parallel to this EGD. And then the other two lines, BGC, which is that middle one, is parallel to EF. Okay, and then the little arrows are the notation that tell you that they're parallel. And it gives us this one angle there, 63 degrees. Okay, find the size of angle X. Now it's a parallel line situation, so we've got our two kind of key terms for parallel line angles. We've got corresponding angles and we've got alternate angles. Okay, corresponding angles are these angles where, if you imagine that 63 degrees there, if you slide it along, you would get another 63 degrees where I've shaded in. Okay, because of the two parallel lines. So it's like a sliding type motion. That shaded part, you can then slide downwards to where X is. Okay, so that is what informs you that X is 63 degrees. It's the same angle, and it just comes from being sliding across the two parallel lines. Your reason is that key word then, okay? Corresponding angles. Doesn't need to be an elaborate sentence, just a nice simple bullet point, corresponding angles. Work out the size of angle Y. Well, if we go back to the picture, the shaded in bit, put a little arrow, was 63 degrees. So what we've got is a straight line. I know that that's 63, so I've got to find out the missing part. So a quick, simple calculation. A straight line is 180 degrees. And if I take away the 63, okay, our answer, 117. Okay, and put it in the box. And don't worry about using a calculator for that. Yeah, it might be a simple thing, but you might as well get it 100% right. Okay, question 4. We've got A, B, C, D, E, F. It's a regular hexagon, okay? And then on the bottom, we've got A, B, Q, P is a square. And then we've got this unknown angle X, okay, just on the right-hand side of that point B. Work out the value of X. Now, essentially what we need to do is we need to work out the other angles, so then we can ultimately work out the X part. I would start with a square. It's the easiest one to do. It will still get you some marks. So a simple, doesn't have to be a lot. Just put something like square, each angle, 90 degrees. Okay, something simple like that. And that just gives us that this one in here then is a right angle. So we're part of the way there. We know that's 90. What we need to get is this hexagon one. Okay. Now the way I've done it, you can actually use for any shape. It doesn't have to just be a hexagon. This is a good technique for any particular polygon, which is the general word for all of them. So what I've got is I've imagined there's a center point, okay, and I'm just going to split this hexagon into lots of triangles. So if you just draw the diagonals across, just need to do 3 extra lines. And this little technique can work on any regular shape. So basically we've split it into 6 triangles. Now what we'll do is we'll go through the process of what we know about these triangles, and then eventually we'll be working out these 2 little angles at the bottom. So the first thing I know is what's happening at this centre bit. Okay. All of these triangles are exactly the same. So I know that I've got a full circle, 360 degrees, and I've split it into 1, 2, 3, 4, 5, 6 points. So if I just do the quick calculation, 360 divided by 6, we work out that each one of those centre angles is 60 degrees. Okay, so 60 degrees in there. Now again, because it is a regular polygon, what we also know is that all of these lines that we drew are all the same. Okay, everything's coming from the centre, so it's effectively like a radius of a circle, only it's obviously not round, but they're all the same length. What that kind of informs us then is that this triangle has got two sides the same. And the triangle that's got two sides the same is then the isosceles triangle. Okay, so using, I'm going to put isosceles triangle. So I'm trying to explain what I'm doing for each little part. So using isosceles triangle. If I know that's 60 degrees, okay, then if I start with 180, which is my full triangle, if I take away the 60, which is the one angle I do know, that gives me 120 degrees left. And the other thing you know about an isosceles triangle is then that the two angles at the bottom are identical. So the two angles underneath the two lines that are equal, they are identical angles. So if you know that both of them have to add up to 120, then by halving 120, we can work out that each one of these shaded ones is 60 degrees. So 60 and 60. And actually what you end up with is an equilateral triangle. Okay, there's 60, 60, 60. And that repeats itself everywhere. So every single one of these is 60, 60, 60. It's an equilateral triangle. So we know everything that's going on in here. This is 60, that's 90. This is the x we're trying to work out. And then because that triangle is the same, that is also 60. Okay? And look, I've drawn lots on that picture. They are not necessarily expecting, but they can still give you marks for notations and numbers and calculations you put on the picture. So it doesn't have to just be in this space. You can add it onto the picture as well. So my final task then, work out what 90 add 60 adds up to, which is 210, and you can just check that on a calculator, okay? We want to know what x is, so it's a full circle, 360, and it would be take away 210. And that's what would be left. And so our answer would be 150 degrees. Okay, question 5. Just give you a second to read that as I'm reading through as well. Mrs. White wants to buy a new washing machine. 3 shops sell the washing machine she wants. So you've got 3 different places: Clean Machines, Electrics, and Wash and Go. And then they've all got a different price structure. So the first shop, buy now, pay later, £50 deposit plus 10 equal payments of £27. Second place is a quarter off the usual price of £420. And the third place, £280 plus VAT, which is 17.5%. Mrs. White wants to buy the cheapest one. She decides to buy it from one of these 3 shops. From which of these shops should she buy the washing machine? And you must show how you decided your answer. So they're telling you you need to show everything. So just start shop A, or I'm just going to write Clean, just to kind of show that that's the one I'm working for. So the Clean Machine shop. Buy now, pay later. £50 deposit plus 10 equal payments of 27. So our calculation there would need to be 50, add on, and then I want 10 lots of 27. Okay. 10 lots of 27, 270, and then 270 add 50, we've got £320, okay? Now, chances are with these questions, you will be expecting your other answers to be around the 320 mark, okay? They're going to be slightly different, but if you end up with something that's like 1,000, you probably made a mistake. They will tend to be quite close. The second shot, electrics. 1/4 off the usual price of 420. So we're trying to work out 1/4 of 420. Okay. Easiest way would be a quick calculation of 420 divided by 4. That's going to get you your quarter. The simplest way. So 420 divided by 4 gives us 105. Okay, and don't forget you need to then take that away from the 420. So 420 take away 105 gives us 315. Okay. And that's pretty close to 320, so I'm going to stand by that I've done something right. You do have to make a judgment call. Wash and go, the last one. Just going to put wash. Okay, £280 plus VAT at 17.5%. Okay, so we're trying to work out that 17.5%. Now, if you remember the trick from last week, I think there was a question for VAT as well. If you work out 10%, you halve it to get 5%, you halve it again to get 2.5%. And all of those add up to the 17.5%. So it's a nice little trick for VAT. So 10%, okay, bearing in mind, it's all from £280. So 10% would be 28. Halve it for 5%, which would be 14. Halve it again for 2.5% would be 7. And then add them together, and we should get 49. Okay. Make sure you've read it right. We are having to plus VAT. So you're going to have to do 280 plus 49. Okay. This is your final calculation. £329. Okay, which again is pretty close, so it gives you an idea that you have done something right. You've done all the maths, you've shown you're working out, you do have to answer the question, remember. So from which of these shops should he buy her washing machine? Well, looking at your three numbers, 1, 2, 3, obviously it's the middle one. So a simple statement, she should buy from the, I'm just going to put electric shop, as it's the cheapest. Okay, you've got the maths to back up that statement, but you do just need to write the actual comment, okay?
Okay, so question number 6 is a conversion graphs question. This is actually quite a nice question for question number 6. You just have to make sure you're being really accurate to make sure you get all the marks. So the conversion graph can be used to convert between pounds and euros. Notice your pounds are on your x-axis, your euros are on your y-axis. For part A, we need to change £30 into euros. So you're looking along your x-axis to find 30. Take your ruler, draw a nice straight line up to the line of the conversion graph, and then you're moving along. And you can see that it's going to be 40 euros. You do have to be really accurate here. The mark scheme allows you anything from 40 to 41. So Not allowed an awful lot of leeway with this one, but it's quite nice because obviously 30 and 40 are marked clearly on the axes. Okay, now we're doing reverse. We're changing 16 euros into pounds. So again, same principle, a little bit harder this time. I've got to find 16. So looking at your scale, you can see that every one small square is worth 1 unit. So you've got 11, 12, 13, 14, 15 and 16. So a little mark there so you know where you're measuring from. Measure along to the line. And then measuring down, and you should get an answer of 12. Again, you're not allowed much leeway. In the mark scheme it says 11.5 to 12.5, so you do have to be really accurate there. Okay, question number 7, stem and leaf diagram. Stem and leaf is a guaranteed topic to come up. So if you're looking at this thinking, I've no idea what a stem and leaf diagram is, you need to make sure you know because you're guaranteed to get a question on it. Okay, the first thing I'm going to do, you're asked to complete an ordered stem and leaf diagram. I'm going to do an unordered one first to make sure I don't miss anything else. So I'm just quickly going to sketch it here with the same stem. So 6, 7, 8 and 9, and I'm literally just going to keep the numbers in the order that they're given to me in the question. So putting in my 90, my 81, my 78, my 83, my 68, my 75, 79, 81, 69, 87, 76, 91, 67, 73, and then the 81. Now I can order it a row at a time. It's a lot easier for me. So I'm going on to the actual one now. So ordering my numbers in my 60s, obviously 67, 68 and 69. Ordering my numbers in the 70s, obviously 73, 75, 76, 78 and 79. Going on to the 80s, so I've got 3 81s, an 83 and an 87, and then going on to my 90s, keeping it in the same order. Really, really important here that you do the key. If you don't do the key, you'll lose a mark. So the key is just basically telling you that you know what the stem and leaf diagram is showing. So I'm going to say 6 line 7 is equal to 67. So that's your 3 marks. Okay, Janine says to find the median time, you add all the results and divide by 15. You're told that she's wrong, and then you're asked to explain how to find the median. Okay, to find the median, it's you put the numbers in order, and then find the middle number. Okay, you're now asked to find the median. Now you've already put the numbers in order, so to find the median from your stem and leaf diagram, cross off the smallest, then the largest, next smallest, next largest, next smallest, next largest, next smallest, next largest. So there is your median. Be really, really careful here. Don't make a silly mistake. I know you've circled the number 9, but obviously 9 is not your median. Look back to your key. Your median is going to be 79. Okay, so for this question, you are going to need a protractor. Okay.